this is section 3.2, graphing rational function. So we are using the uh, the vertical asymptotes, and then maybe the horizontal asymptote, which makes the end behavior, and the whole to graphing the rational functions. So objective number one, graphing strategy for rational function. Number two, rational graphs with the whole. And the rational graphs has across the end behavior asymptotes, which is the horizontal asymptote. So graphing rational functions. The topic of the vertical and behavior asymptote from the section 3.1 will now become the beginning of the process for drawing the graphs of rational functions. The following list below is a quick summary of the topics from the last section. So first one, if the rational function has a numerator and denominator that are factorable, write the function in the factor form. If the function has a common factor in both numerator and denominator, and then write the third version of the function, which is simplest form, which makes the expression that has cancel will makes the whole. Determine the all vertical asymptote location of the whole in the graph by the setting the denominator equal to 0. Determine the end behavior asymptote of the function. So case 1, the degree of numerator is less than degree of denominator, which is n is less than k. And then y equal to 1 is always horizontal asymptote. Case 2, if the degree numerator and the denominator are the same, n equal to k, and then the rational function will have the end behavior approaching the horizontal asymptote as y equal to a over b, which is a leading coefficient ratio, where a, b the leading coefficient of the numerator and denominator is respectively. Case 3, if the degree of the numerator is greater than the degree of denominator, then the rational function will have the end behavior approaching the slant asymptote, which means y equal to mx plus b. Can be determined using division, which is a long division. At this point in this process, we'll have the dashed line that is not a part of the actual graph, but will control some of the behavior of the rational functions. After asymptote has been drawn, we will not set out to find the important point for each graph, as with the polynomial function. So we will find and then plot all the intercepts. So first thing, find the y-intercept, which is you always set the x equal to 0. Find the x-intercept, which means set the f of x equal to 0, function equal to 0. If the graph has n behavior asymptote that is not the x-axis, and check to see if the graph will touch the asymptote. Recall that the vertical asymptote divide the graph into the pieces, and the graph each of the rational function finding points if necessary. To shorten the discussion for each problem in this section, we can use the following template to determine all the key information needed to graph a rational function. So vertical asymptote, which means set denominator equal to 0. And behavior asymptote, it depends on the find cases, which is the degree of the numerator denominator. Y-intercept, which means 0 and b. X-intercept is a and 0. And check if the graph touches the end behavior of the asymptote. So I'll tell you what it is, which is we need to use a horizontal asymptote set with the rational expression. So draw the graph one piece at a time. Okay, so we'll work graphing. So first one, we draw the graph of f of x equal to x plus 1. So first one, the vertical asymptote. Which means this time is asymptotes. X squared minus 4 equal to 0. So, which is add for both sides. X squared equal to 4. So, x equal to plus minus square root of both sides, right? And then 2. So, you got x equal to 2. Okay, I think I want to get better right away. Okay, so this is it. And then then we're looking for the y-intercept. which means 0b. So we're using f of 0 to plug it in. So 0 plus 1 over 0 squared minus 4, which is negative 1/4. So negative 1/4 about here. Let's use the points over here. Yeah, this is it. And then number 3, x intercept, which means a and 0, okay? So we put the 0 f of x, and then x plus 1 over x squared minus 4. And then if you multiply by x squared minus 4 both sides, and this cancels out, 0 equal to x plus 1. So x equal to negative 1, which means it becomes negative 1 and 0. So negative 1 and 0 is right here. Okay? And then we want to check that the end behavior, okay, end behavior, which means the horizontal asymptote. Which means this time is a degree is 1 degree of 2, which is less than, which means the horizontal asymptote is y equal to 0. So this is a horizontal asymptote right there. And then since the horizontal asymptote actually has a point, so this is actually has some point, which is that'll be all. So what we need is, I want to make the extra points, which is, let's use a red for this one. Sorry about that. Number 5, I'm going to make the extra points to get better graph, okay? So this time, I think I want to get to the point next to the vertical asymptote. So I think I want to use x equal to 1 this place. It's a 1. It's a good one to use. And the right side of this vertical asymptote, which is going to be this is a 2, so I want to use a 3. And then for this side, I think I want to use the negative 32. And then plug it in. So f of 1, you got 1 plus 1 over 1 squared minus 4. You got 2 over negative 3, which is negative 2/3. F of 3, 3 plus 1 over 3 squared minus 4. So 4 over 5. And then f of negative 3, you got negative 3 plus 1 over negative 3 squared minus 4. I got negative 2 over 5. So negative 2/5. So if I plug it in, 1 is actually the negative 2/3, so about here. And this is minus 0, isn't it? So your graph is going to be connected. Of course, the graph actually try to get close to the asymptote, so which is a vertical asymptote, but not crossing it, okay? And for the x equal to 3 is a positive 1/4, very close to 1, yeah. So this is what you get. And then for the negative 3 is a negative 2/5, which is about here. And then your graph's going to be this. Okay? So think about it, okay? So because when you have a vertical asymptote, graph actually getting close to the vertical asymptote, but not touch or crossing. For the second one, now the vertical asymptote, which is 2x plus 1 equal to 0, denominator equal to 0, x equal to negative 1 over 2. Negative 1 over 2 is about here. Okay. All right, number 2. Y-intercept, plug it in, a g of 0. So 3 times 0 minus 4 over 2 times 0 plus 1 is a negative 4. So there's a negative 1, 2, 3, 4 right here. Which is, I think I want to use the red for this graph. And then, oh, sorry about that. And then x-intercept, which means the y is a 0. So g of x is 0 of 3x minus 4 over 2x plus 1 multiplied 2x plus 1 both sides. And then you got 0 equal to 3x minus 4. So for x is a 4/3. So x-intercept is a 4/3, which is about 1 and 1/3 right here. Sorry, let me use a red. Okay. And then number 4. horizontal asymptotes, which means the degree is 1 and degree of denominator is 1. It's the same, so which is y equal to 3 over 2, which is 1.5. So 1.5 is about here, right? So asymptotes, I'm using the blue. Okay. And then, do you think it goes through the horizontal asymptotes? I can check with that. But in this time, actually, if you, no, I don't, oh, okay. So I want to say, set the horizontal asymptote 3 over 2. So in order to find the any intercept from the horizontal asymptote, you need to put the 3x minus 4 over 2x plus 1, and then set equal to the horizontal asymptotes. And then when you cross multiply, I don't think there's a happen for this one though. So 2 times of 3x minus 4 equal to 3 times 2x plus 1. 6x minus 8 equal to 6x plus 3. And subtract 6x both sides. As you notice that, negative 8 equal to 3, which is not true. So no intersection on the horizontal. So on this case, the good thing is you have a 2 points on here to here. So it's getting close to asymptotes on vertical and horizontal, okay? But other sides, I need to use a table. This time I want to make a table, which is next to the negative 1/2. I think I can use the negative ones. I think that's enough for that, okay? And plug it in. So g of negative 1, 3 times negative 1 minus 4 over 2 times negative 1 plus 1. I get negative 7 over negative 1, which is a 7. So it's right here. So this is a 1, 2, 3, 4, 5, 6, 7 right here. So which means you're gonna have a graph like this. Okay, so that's for the example 2 graph. All right, example 3. Now draw the graph of the g of x, which means first one, the vertical asymptote, which is denominator equal to 0, so x equal to 3. So 1 to 3 right here. Okay, y-intercept. Set x equal to 0. So q of 0, which is 0 squared minus 1 over 0 minus 3 is 1/3. So it's about 1/3 here. Okay, let me use the red. Okay, number 3, x-intercept. So this time x-intercept, you gotta set the q of x equal to 0, which is x squared minus 1 over x minus 3. Multiply x minus 3 both sides. You got 0 equal to x squared minus 1. Add 1 both sides. X equal to what? Plus minus 1. So x-intercept, 2 x-intercept, which is 1, 0. And then negative 1, 0 this side. That's x-intercept this time, okay? Alrighty, so, and then number 4. Horizontal asymptote, which is, this time, yeah, there's no horizontal asymptote this time. There's none. Because degrees of 2, degree of 1, which is the case, isn't it? That means there's no horizontal asymptote. So that if there's no horizontal asymptote this time, we might have a slant asymptote. So how do you find it? Divide it. So x squared minus 1 divided by x minus 3. So x squared divided by x is x, which is x squared minus 3x. Oh, so this time actually there's a missing term, so you should have put it as better as a 0x minus 1. So subtracted and added, subtracted it, you got 3x minus 1, add plus 3, and then 3x minus 9, so 8, but denominator is not important, so this is it. So slant asymptote is this one, which is from 3, so 1, 2, 3. Okay, let's do the red, blue, okay. Yeah, so this is a slant asymptote. So this is it. Okay, so this time, yep, but the graph never touched the slant asymptote and will cross the slant asymptote anyway. So we have a graph here already, the points here. So which is, this is what happened. So what we needed is, I just need to find the more points from the vertical asymptote. But you only have a vertical asymptote as 1, which is x equal to 3. So I want to use 4. So plug it in. So Q of 4, which is 4 squared minus 1 over 4 minus 3. I got 16 minus 1 over 1, which is 15. Oh my goodness, it's very top. So, which means it's right up here, right? So yeah, so you see that any reflection looks like the other side. Okay. All right, let's grab the example 4. I think that's the second graph from here. Okay, so this time same idea. So number 1, vertical asymptote. So x squared minus 9 equal to 0. And 9 both sides. Square root both sides with a plus minus. X squared equal to plus minus 3. So you have a 2 vertical asymptote this time. Okay, and number 2, y-intercept, which is f of 0. So 2 times 0 plus 6 over 0 squared minus 9, which is negative 6 over 9, which is negative 2/3. So y-intercept is negative 2/3. So about here. Okay. And number 3, x-intercept. So x-intercept this time is set f of x equal to 0. And then 2x plus 6 over x squared minus 9. And multiply x squared minus 9 both sides. And then you got 0 equal to 2x plus 6. Subtract 6 both sides. Divide by 2 both sides. X equal to negative 3. So negative 3. Oh, so what I miss is, okay, there's no 2 vertical asymptote this time. Okay, sorry about that. So what I do in here, okay, I missed it. Sorry about that. It's kind of getting big. So if you factor it out, oh my goodness, there's something wrong in here. And then you can cancel this out. So we are actually graphing the 2 over x minus 3. So in here, instead of getting a plus minus 3, in this time, vertical asymptote, we have to put the x minus 3 equal to 0. So only we can get the vertical asymptote is x equal to 3. So I didn't know until, see. So x equal to 3. So that's the one we have. But y-intercept is the same. X-intercept will be the same too. But we have actually, since the x plus 3 is a cancel, so x equal to negative 3 places, actually instead of the, it could be the x-intercept, but it makes a whole this time. So what I do is, you plug it in negative 3 in here. So instead of the setting up, okay, so 0 equal to, yeah, same thing, 2x, so x equal to 2 goes 6, negative 3, right? So what I do is, this, instead of the x-intercept, I don't think that makes the x-intercept, it makes a whole. So what I do is, you plug it in this f function. So f of negative 3, you got 2 over negative 3 minus 3, it's going to be 2 over negative 6, it's a negative 1/3. So negative 3 and negative 1/3 is a whole. So negative 3 is right here. It's a whole. So I should have made a little bit better one. Okay. So it's going to be a whole in here. Do you see that? All right. So next one. Number 4. And then the horizontal asymptote, yes, there is. So degree is 1 and degree is 2, so less than. So horizontal asymptote equal to 0. So this is actually the horizontal asymptote this time. But is there any intersections on the horizontal asymptote? Let's think about it. So what I do is, I just said 0 equal to 2x plus 6 over x squared minus 9. Oh, you know what? Let's not do it this way. Okay, we need to actually do this one to use. That's why I just mess up with it here. So x-intercept, let me erase this one. Yeah, this is not true. So in here, you just use a f of x equal to 2 over x minus 3. So 0 equal to 2 over x minus 3, multiply x minus 3 both sides. And then 0 is not equal to 2, so there's no x in a set. Okay, there's no x in a set this time. So, which means actually there's nothing you can go through, okay? So if I graphing it, you get the graph of whole going through this way. And then to number 5, using the more point, find the more point, I use the right side of the vertical asymptote, which is a 4, and then plug it in. So f of 4, I got 2 times 4 plus 6 over 4 squared minus 9, 8 plus 6 over 16 minus 9, over 14 over, actually isn't it 7? Oh, which is 2, isn't it? So okay, so 4 and 2, which is not bad. So 4 and 2 right there, which means you have another graph that looks like this. That's another graph. Okay, the last one, actually the good thing is that we have more space. So this time I shouldn't forget the factoring. It's a factorable. So 4 times of x squared minus 1, which is factorable more as 4 times x plus 1 and x minus 1. Denominator is x plus 4, x minus 2. Oh yeah. So x plus 4 and x minus 2. Which means there's no cancellations. Okay, so there's no hole this time. Okay, so number 1, vertical asymptote. So I set the denominator, which is x plus 4. It's better to have a factor form, okay? So x equal to negative 4 and x equal to 2. So negative 4, 1, 2, 3, 4 about here. X equal to 2. Okay. And the y-intercept, which is p of 0. So 4 times 0 squared minus 4. 0 squared plus 2 times 0 minus 8, which is negative 4 over negative 8, 1 over 2. So y-intercept is 1 over 2 over here. Let me use the red, okay? Okay, x-intercept. Set p of x equal to 0 of 4x squared minus 4 over x squared plus 2x minus 8 multiplied by x squared plus 2x minus 8 both sides. So you got 0 equal to 4x squared minus 4, and then 4x squared minus 1 divided by 4x squared minus 1 plus 1 both sides, 1 equal to x squared, square root both sides, plus minus 1 plus minus 1 equal to x. So we have a 2x in a set, 1, 0 and negative 1, 0. Okay, now the horizontal asymptote, which is degree of numerator is 2, degree of denominator is 2, all equal to, right? So we got y equal to 4 over 1, because that's a leading coefficient, 4 over 1. So which is a 4? So 1, 2, 3, 4 right here, right? So this is horizontal asymptote this time. Okay, we might have an intersection of the horizontal, I don't know. So let's check it out, number 5. Which is the horizontal asymptote is a 4 that equal to the expressions of 4 times x. You know what? 4x squared? I think that's just the original one. It'd be better. Okay. So 4x squared minus 4 over x squared plus 2x minus 8. So cross multiply. I got 4 times of x squared plus 2x minus 8 equal to 4x squared minus 4. So 4x squared plus 8x minus 32 equal to 4x squared minus 4. Subtract 4x squared both sides. I got 8x minus 32 equal to negative 4. Add 32 both sides. 8x equal to, which is 828. And the x equal to 28 over 8, which is 7 over 2, which is about 3.5. Oh, so they're actually the touching it. So 1, 2, 3, right there. So actually, it's touching it. There's the intercept. Right there. 1, 2, 3.5, right? Okay, so let's do some graphing here. So let's see what happened. So number 6, table. So I think I'm gonna use the next to this vertical asymptotes, which is -4. So I'm gonna use -5, maybe -3, and then I think this is enough as a 1. So go to 2, maybe 3. Okay, so plug it in. So P of, plug it anywhere, but plug it into the maybe here. Why not? So P of -5. So 4 times -5 plus 1, -5 minus 1, -5 plus 4 over -5 minus 2, which is 4 times -4 times -6 over -1 times -7. Okay, which is no cancellation. So I got 16 times 6, which is 96 over 7. 96 divided by 7 is about 13 over, about 13.7, okay? So about, yeah, 96 over 7. And P of -3. So 4 times -3 plus 1, -3 minus 1, over -3 plus 4, -3 minus 2. So I got 4 times -2, -4 over 1 times -5. Okay, so 16 times 2, which is 32 over -5. So -32 over 5. This is about 13.7. And this is about -32 divided by 5, which is about 6.4. And then 3. I have P of 3. So 4 times 3 plus 1, 3 minus 1 over 3 plus 4 over 3 minus 2. So 4 times 4 times 2 over 7 times 1. So 32 over 7. So this is 32 over 7, which means 32 divided by 7 is about 4.6. Okay, so -5 is right here to 13 over 7, somewhere right here, isn't it? So this is a graph of this. -3 is a -6.4, so 1, 2, 3, 4, 5, 6.4 right here. Oh, okay, so this graph looks like this. That's it. And then x equal to 3 is going to be the 4.6. So 1, 2, 3, 4. Yeah, about here. Oh, so actually this touching the horizontal asymptote, but it goes a little bit down and somehow it goes back to this way. Oh, not crossing. Sorry. What am I talking about? Sorry about that. So it actually, the crossing it, and then it goes down, but a little bit up, but still getting close to that asymptote too. Okay, so that's for the, yeah, this has a lot of work. All right, thank you for listening.